The next functional group are halides. Sometimes you might see the word alkyl halide. Alkyl just is a fancy word for a carbon-hydrogen chain. But the important part is the halide. Okay, so you have your halogens. The best way of showing it is a carbon with an X, where X can mean either fluorine, chlorine, bromine, or iodine, or iodine. It's actually pronounced iodine, but we call them iodine. So you can have an alkyl fluoride, an alkyl chloride, an alkyl bromide, an alkyl iodide, just all depending on what the group is. All right, so, and again, at these spots here, you can either have hydrogens or carbons. In this case, you can also have other halogens. So an example is dichloromethane. All right, we'll actually use this in one of our labs. We're going to be using dichloromethane. And it's a carbon with exactly how it sounds, 2 chlorines. Methane is a 1-carbon molecule, which again we will learn naming in this chapter. Right now we're just learning the functional groups, but you can see you have 2 chlorines. So this is technically also an alkyl halide, an example of an alkyl halide. Right. The next functional group is an alcohol. This is a very common one. So the alcohol functional group, as I kind of showed you earlier, is a carbon with an oxygen and a hydrogen. And at these spots right here, again, you can have other carbons or hydrogens. I showed you ethanol as the one example. But there's all types of alcohols. The next one is ether. An ether is a carbon attached to an oxygen attached to another carbon. Okay, a little different than it's very similar to an alcohol, except in place of one of the hydrogens, you have another carbon. So that is what's called an ether. Okay, I have a little joke. Let's kind of do a little joke, because what is organic chemistry without funny jokes? Okay, so please just bear with me. All right, what would you call that? That is called, what do you think? Looks kind of silly, doesn't it? This is called an ether bunny. I know right now you are sitting there just cracking up. Unfortunately, I'm not there to witness it, but it's all right. You can tell me later in class that you thought that was a good joke. All right, so that is the ether bunny. All right, so you'll never forget it. It's the oxygen with 2 carbons on either side for the eyes. And all right, let's just move along here. Next one is an amine. All right. Oh, I'm skipping monophosphate. As you're going down the list, notice I'm skipping the monophosphate. Next one is an amine. An amine is a nitrogen with 3 groups. Okay. One of the groups has to be a carbon. You have to have at least that. The other 2 groups can either be hydrogens or carbons. Okay, so that is an amine. If all 3 of them were hydrogen, just to kind of show you why one has to be carbon, if all 3 of them were hydrogens, this is not an amine. This is ammonia. All right, and obviously this is not organic. There's no carbon on it. So that's why amines have to have at least 1 carbon on it for it to classify as an amine. The imine, I'll write it because we will briefly talk about it this semester. It's not something I'm going to emphasize too much on, but an amine is a carbon with a double bond nitrogen. And you can have a hydrogen in this place. You can also have a carbon. I wrote a hydrogen, but technically you can have a carbon there as well. A nitrile group we'll talk a little bit about this semester. Nitrile groups are carbon triple bond N. That is a nitrile. So this group right there is the nitrile group. Nitro groups, in your book, they drew it out in the full Lewis structure. So let me do that just to kind of show you. You have a negative charge on the oxygen and a plus, so they're just doing the formal charge for a nitro group. Shorthand way of doing this, which is how you'll probably see me doing it throughout the semester, is you just write NO2. That's it. It's a very simple way. of doing a nitro group. All right, and thiols and sulfides. Yeah, I guess we'll go over that. Again, a lot of these we're not going to emphasize too much on, but there's certain groups that you should know. A thiol is like an alcohol. Notice it ends in OL, just like alcohol. The thio part of it is kind of an old way of naming something that has a sulfur molecule on it. So that's thio. So these are thiols with the sulfur. So it's kind of like an alcohol, but with a sulfur instead. And a sulfide is kind of like an ether, but with a sulfur. I don't have any funny jokes for this one. Alright, so that's a sulfide. These compounds smell really bad. Anything with sulfur has like that rotten egg smell to it. And we're going to skip disulfide. If you do take a biochemistry course, you will learn a lot about disulfides, but we don't really need to talk about it in here. Now, the remainder of the compounds have this special group to it. This is not a functional group. Okay, I'm going to put here, not a functional group. This is just part of the functional group. All right, and that would be a carbonyl. Okay, a carbonyl is just a special group. It's a carbon with a double bond oxygen. Okay, and it doesn't really matter what is over here. This part of it is the carbonyl. So any of these molecules, notice there's an aldehyde. If you look on your list, aldehyde, ketone, carboxylic acid, ester, amide, carboxylic acid anhydride, carboxylic acid chloride. They all have this carbonyl group. They all have a C double bond O. Okay, that's just part of the group. It's kind of the analogy I use is like I have a car. Okay, car would be the whole thing, and a steering wheel happens to be a part of the car. All right, it's not like, oh, I drive a steering wheel. All right, I drive a car, and the steering wheel just happens to be part of it. Just like these, an aldehyde. Okay, the aldehyde functional group is very specific. Okay, it's a carbon with a carbonyl and a hydrogen attached to it. Okay, so again, the carbonyl is not a functional group. It's just part of all of these other functional groups. Okay, so the aldehyde has a hydrogen. How I always remembered it is aldehyde has an H in it, just like an aldehyde does. Okay. Next one is ketone. A ketone is like an aldehyde, but now you have carbons on both sides of the carbonyl. Okay, so your frame of reference is the carbonyl, and then whatever you have around it dictates what the functional group is going to be. All right, one of the most common ones is acetone. Everyone's pretty much heard of acetone. Acetone is in like a nail polish remover, paint thinners. It's in a lot of things, and basically it's the simplest ketone, where you have 3 carbons and your carbonyl in the middle. So that's acetone. The next one is carboxylic acid. We talked about this one already, but we will do it again. Carboxylic acid. These are the most acidic of all of the functional groups. So notice you have a carbonyl, but this time you have an OH on one side of it. So you can look at it, it's like an alcohol with a carbonyl, just like the example I gave you at the beginning to kind of explain what a functional group is. That's what a carboxylic acid is. The next one is an ester. Some people get ethers and esters confused just because the names are very similar. The structures are kind of similar too, depends on how you want to look at it. But it is a carbonyl with an OC. So if you replace the hydrogen of a carboxylic acid with a C, you'll have an ester. So that's what an ester is. An amide, or amide, depends on how you want to pronounce it. I pronounce them amides, is a carbonyl with a nitrogen. So like an amine, but with a carbonyl. Next one is, they call them carboxylic acid anhydrides. I'm just going to call it an anhydride because that's really what most people call it. You don't call them carboxylic acid anhydrides. That's just kind of a mouthful. No reason to do that. This has 2 carbonyls flanked on either side of an oxygen, and then you have carbons on either side of that. So that is an anhydride. Finally, an acid chloride. Again, you don't have to use the word carboxylic acid chloride. These are called acid chlorides. Chloride. DE. Acid chloride looks like a carboxylic acid, but you have a chlorine on one side of it. Acid bromides and acid iodides do not exist. It's just mainly the acid chlorides are the ones that you have. Okay? So, like I said, the best thing to do is have a flashcard. Maybe on one side of the flashcard have the word alcohol. And then maybe on the back side, I don't know how to draw that, but that's good enough. On the back side of the, maybe have the general form, or maybe have an example of one. And that's the best way in order to memorize the functional groups. There's going to be a bunch of questions in your homework about it. And functional groups are important to know because it's important to know because by looking at a molecule, you can really tell a lot about its chemical and physical characteristics just by looking at the functional group. And without even knowing what the molecule even is. By just looking at that, you can tell if it's acidic, or if it's a base, or if it's neutral, if it's volatile, or if it's going to be a solid at room temperature. These are types of things that you can get just by looking at the functional groups, which we will learn throughout the semester. The other thing is that molecules can have more than one functional group on them. Okay, that absolutely is able to happen. So, again, that will also change the characteristics of the molecule.